Hi everyone, I'm Jack Rusk, Director of Climate Strategy at EHCD, and here today to talk about EPIC, the Early Phase Integrated Carbon Assessment. EPIC is a low carbon design tool meant to be used at the very beginning of a project's design process, where information about that project is relatively scarce, but some of the largest and most impactful decisions that will affect the project's decarbonization potential are being made. Rather than waiting until BIM, a BIM is available or a bill of quantities exists, the idea of EPIC is to front load the low carbon decision making to make sure that the most impactful directional decisions are being made. EPIC has been cited in research and used in practice by industry leaders. We've gotten great feedback from partners at Architecture 2030, Rocky Mountain Institute, and Carbon Leadership Forum. And the idea of EPIC as an early phase tool, open access, available to everybody in the industry, is twofold. One, to help firms win more projects by being able to present low carbon strategies during the interview phase and in response to RFPs, and to scale climate action by making sure that these strategies are available to everyone working across the industry. EPIC is one part of an iterative low carbon design process. So if you're using EPIC during the RFP and pre-SD stages to sketch out strategies, the data, the advice, and the strategies determined in EPIC and explored there are then become things that inform the energy modeling process, the LCA process using tools like Tally LCA and EC3, and the site design process using tools like Pathfinder. So with all that context in place, let's dive in and use the tool. I already have an account, so I'm just going to log in with my username and password. If you don't already have an account, you can set one up for free with a login flow similar to many other web applications. Once you log in, you come to your dashboard page. This is, we'll have a list of projects on the left and a quick kind of getting started guide on the right. I'm going to dive in and create a new project. We have a disclaimer. This disclaimer says that EHDD, try as we might, cannot predict the future. Because EPIC contains data like, for instance, how the electricity utility grids will decarbonize over time, some of its predictions are inherently uncertain. For instance, we made a prediction using data from the National Renewable Energy Lab of how building emissions would decrease. We made that prediction before the Inflation Reduction Act was passed. We made it after. And these two predictions were totally different because the IRA hastened enormously the decarbonization of the electrical grid. We could not have predicted the passage of the IRA before it was passed. So as the policy landscape and the technologies available evolve, our predictions will as well. So the future is inherently uncertain, and EPIC has to sort of wrangle with that. I'm going to sketch out the whole life carbon emissions for an architecture office completed in 2025 in San Francisco. Let's say it's reinforced concrete as a baseline. Let's say it's an office building with 2 floors, each of 20,000 square feet. The baseline in EPIC is always sort of a typical new building, and I can show you how to model a retrofit and reuse. So this is the sort of baseline carbon emissions of that building. You can add more information here, below ground floors, a site. You can override a lot of EPIC assumptions. We take our benchmark EUI, for instance, directly from Zero Tool, which is also used in the AIA DDX reporting. But if you want to enter a code-specific benchmark EUI, go right on ahead, et cetera, down here. With all of these overrides, though, we have the caveat that entering unrealistic values may yield unrealistic results. So tinker as you'd like, but be sort of like cautious as you're overriding those assumptions. A few things to demonstrate on the base case tab is the effect of the project's timeline and of its location. Mentioned earlier, the electrical grids are expected to decarbonize over time. So if we actually say this project is completed not in 2025, but in 2030, we see that the operational emissions are relatively lower. This means that the electrical grid between 2030 and 2060 will be relatively cleaner than it is between 2025 and 2055, right? Different kind of 30-year time slices. As you move out, that 30-year time slice is cleaner and cleaner. Another thing that we can investigate is the effective location. I'm going to move this back to 2025, and we're going to move this project from San Francisco, say, to Washington, D.C. So right now we're looking at 2800 and 3700. If I move to Washington, D.C. at this postal code, we see lower embodied emissions and much higher operational emissions. So this tells us that concrete, which is the sort of major structural material in this baseline building, EPDs that are available in the Washington, D.C. metro region have a relatively lower carbon intensity than those I'm seeing around San Francisco, and that the grid that we're connected to in D.C., which I think is PJM East, has a much higher carbon intensity into the future than that we're seeing in California. So again, really strong effects of location in these models. We'll move back to California for this sort of analysis, since that's where I am now. All right, awesome. With the base case very simply set, let's move forward and let's plan some reduction strategies. So I go base case to reduce emissions, and then I can go to the compare tab after that. The first thing that you always want to test is what's the effect of, we'll call it reuse alt for an alternative building or reuse instead of building new. Say for this reuse strategy, we find a building that can provide about the same floor area and we can reuse 80% of its structure, so only a little bit of structural work needs to happen. Say we're going to reuse none of its roof, the entire roof needs to be replaced. We can reuse 50% of its cladding. We'll reuse none of the glazing, some of the fit out, and actually most of the MEP, maybe distribution we can keep, some of the equipment will be new, so I'll say, sort of as a first guess, 40% of the MEP in the existing building can be replaced. Okay, so with that, we'll go into some operational carbon reduction measures for this reused building. It'll be an all-electric retrofit that we do of this existing building. And we'll target an EUI in this. We talk to an engineer, say, on the team, and we can get to an EUI of around 35 for this existing building. Of any concrete, additional concrete going into this building, we'll make sure it's low carbon concrete. So that's the 20th percentile of regionally available concrete. And from this, we'll call our reuse building scenario. So from this, I'll make a new scenario, a new empty scenario, and I'll make this one, we'll just say it's sort of the classic operational net zero building. So for this operational net zero building, it'll also be all electric, taking the sort of clean electrification approach. We're going to size a PV array that'll make up 100% of that building's load. You'll see an increase in embodied emissions from that PV array in year one, and decreasing over time. Let's say we try to achieve this with an EUI of 30 instead of 70, and you can track these numbers here, the PV array area and the capacity. Okay, if our building had 20,000 square feet, right, that was the floor plate size. I'm going to see if I can achieve an EUI of 20 in this net zero new build, and that means we need around 14,000 square feet of PV. I think this is doable on the sort of footprint that we have. So that's another point of comparison. And let's make some new scenarios. So I'm going to make another new scenario. This one will be a copy of the current scenario, and that'll be net zero operational, we'll say plus low carbon design, low carbon structure, we'll say. And here, so there's no retrofit or reuse strategies here, operational carbon strategies as above. Say this structural system instead of reinforced concrete, because this is only a 2-story building, what's the possibility of using a light wood frame sort of structure here instead? We see a significant reduction in first year embodied carbon, likely due to the material efficiencies of light wood frame, and the fact that we're replacing relatively more carbon intensive materials with relatively less carbon intensive materials. Still here, we're going to reduce the concrete carbon specification. We see some reduction there. And the timber specification will have relatively low carbon fossil emissions. And in addition to addressing the fossil emissions from timber specification, we're also going to work to procure responsibly sourced timber. So we're going to make a claim that this timber is sourced from a transparent and traceable supply chain. By making this decision at an early phase of the design, I know that I should be targeting this with any of my timber suppliers, and that this timber, say, is certified, the forest has a growing carbon stock. You can read more about these choices at this question mark to help you understand when you should or should not claim climate benefits from timber. And all of the work happened here was really with guidance from the Climate Smart Wood Group. So thanks to them for the help in determining those options. So by making those options, you'll see there's a little bit of carbon sequestration that this light wood frame building now has, moving the net emissions line just below, right, the overall sort of emissions in each year. We'll also make sure that in this new building, we're going to reduce the envelope carbon emissions by specifying a low carbon envelope, low carbon fit outs. And also importantly, I'm going to make sure this fit out is long lived by selecting a 20-year instead of a 10-year refurbishment period. And you'll see these replacement periods even out over time there. So I didn't model a site in the base case. I'm not going to model a planted roof. And finally, in this building, because it's a new build and we're trying really hard to reduce emissions, I'm going to make sure, in collaboration with the engineers working on the project, that we're going to do our best to specify non-HFC, low GWP refrigerants. And you see the refrigerants part of the pie reduce as well. Cool. So with all these scenarios set up, now we can go to the Compare tab and see what they look like. So we see here, here's some things I've set up. So here's my reuse scenario. Looks like the title didn't totally track for that one. Operational net zero and operational net zero carbon. I'm going to rename this reuse scenario since it didn't seem to catch. And this was reuse alt. Oops, and it was all electric with an EUI of 40. Awesome. Okay, so now with all of these set, I can go here. This will update. So I have my base case, my reuse alternative, my operational net zero, which I'm seeing already interesting patterns here, right? My reuse alternative, even though it doesn't achieve classic net zero, it's lower carbon across the entire time series compared to this operational net zero building. Because this operational net zero building does not, right? It doesn't address the embodied carbon in the structure. And this strategy, operational net zero plus low carbon structure, is able to achieve lower carbon emissions over time, even compared to the reuse building. So this is a pretty interesting set of results that I can then take to my client to help them understand the relative trade-offs of each of these strategies. You can also get a comparison by category. Sometimes these bars don't line up. My apologies. You can toggle something on and off, and then they will. You can also rearrange these bars by dragging these stickies to get a pretty good idea of the way all these strategies stack up against each other. And this is the sort of figure that we see users of the tool often put in their slide decks to help understand the way that all of these measures work together to support low carbon design. So this is the quickest introduction to EPIC. There's a lot more richness in here. I'll illustrate two more options about EPIC. But once you're able to sort of make a base case and make some scenarios, you've gotten 80% of the way there. And I hope this tutorial helps you do that quickly and efficiently. The first thing I'm going to show in the base case tab is the refined scope modal. This helps you turn on or off different parts of the analysis. This modal is, this panel is roughly divided into life cycle phases and building components. There's feedback between these. This is really just meant to simplify these decisions. Refrigerants, for instance, those are counted in phase B1, but they're listed as a building component sort of for simplicity's sake. If I turn off some parts of this, say I'm not going to count embodied carbon from building systems, and I'm not going to count site and landscaping, you'll see that that'll affect the embodied emissions. The embodied emissions have gone down, not because I did anything to reduce them, but just because I'm no longer counting those emissions. I would say, just as a preliminary kind of guiding idea, that it's important that the scope of analysis on a project always matches the scope of work. So if something like MEP and PV is in the brief, then it should be in the emissions analysis, even if data is scarce, to avoid shifting burden into the areas where you're not counting. We see here now probably a different set of patterns in these comparisons because we're no longer counting, right, carbon emissions from the solar photovoltaic array that we installed. So you see here that, yeah, there it is. So you see this, actually the reuse is, they're a little more comparable, and they cross over at an earlier point because I'm excluding the carbon emissions associated with the installed solar PV array. Another thing you can look at here that is an interesting new feature is the analysis period. Defaulted to 30 years, you can also have a 60-year analysis. You see, obviously, because you're accruing the operational emissions over 60 years instead of 30 years, a relatively larger contribution from them. And you get these kind of rich 60-year analyses that help you understand the way that emissions will evolve, emission profiles evolve over longer periods of time. So that's sort of a fun feature to play with as you're moving through the tool. The last thing I'll note too is if sometimes you have partial data from a life cycle assessment that you want to use for some assemblies, but use Epic to do gap filling otherwise, I'll make a new scenario here. It'll be a new empty scenario. Let's say a copy of the current scenario, actually. And we'll take this and we'll say we've modeled out our envelopes. So I'll put this plus custom envelope. I'll go to this refine data to enter project specific data. And I know that my cladding for this building will have a carbon intensity of, we'll say 4.7 kg CO2e per square foot of cladding. My glazing will be 11.5. And I actually don't know, I haven't modeled any of these other things, but I can replace these data using tools, say, from Payet Kaleidoscope or similar. So I'll accept those changes. And it'll use, instead of Epic data, it'll use that data, your user entered data. And you'll see here now, for the envelope choices, you're no longer able to select them because you've overridden some parts of them with a custom input. So you get locked out of the sort of classic Epic choices. You see this red dot appear here telling you you've entered something there. And you're able to use some custom data and some Epic data to model in a little more resolution. The last thing I'll note, maybe before this tutorial ends, is that in addition to searching all these question marks to get more information on the tool, you can also get in touch with us directly using this Get in Touch link here. This will take you to a Google form where this will go basically directly to our internal inbox, and we respond to these every week or two, and you can use it to report bugs, get a direct response to your feedback, or just ask questions about the tool or its use. So thank you all so much for watching this tutorial, and I look forward to hearing your questions, and I appreciate your efforts in bringing low carbon design into your workflows on your projects. It's really going to take everybody across the industry to get where we need to be. Thank you all so much, and have a great day.